have a scroll, and this scroll is part of a map that's going to lead us to the room with all the answers in the whole entire school. Right now, we are in a school that looks like this. Here, we have a circle. You see, here is another circle, and then here's another circle, and right at the center of the very middle circle is where the answers are. We are currently on the outside of the circle, and we will be making our way to the middle. All right, let's see what the scroll has to offer us. Let's see. Alrighty. Okay. First of all, we need to explain some math terms for you. This right here is an arc. This is a radius, and this is a whole circle, obviously. All right, so as we can see here, there are two different kinds of angles. Now, I'm going to refer to my math Bible, which I love very dearly, to help us decrypt this real quick. All right, now here's my ruler, just in case. All right, let's see. Now, this map that we have been given looks similar to this picture, doesn't it? All right, so the central angle is this angle, which has the intersection point at the very center of the circle. And then the inscribed angle is this angle, which has its intersection point, and it is not at the center of the circle. Ah, very, very interesting. All right, we are here at point B, and we are going to get to point A to go into our second circle, as you can see here. All right, let's go. I have my math Bible, don't worry. All right, so here we are, and we have found our second circle. We are now in the second circle of the school, and we are right here at point A. Now, we need to get to point J, because that's going to lead us to the next circle. All right, let's see. Now, this map looks similar to this picture, and this picture tells us that when the perpendicular from the center of a circle to the chord, which means that when a chord, that's this section, is perpendicular to the radius, this section, then the chord is split directly in half by this radius. All right? So our path is going to go down and then make a sharp right angle right to point J, because it's a right angle right here. And then these two sections are both the same length. Now, on this page of the math Bible, we have the other flap, which looks similar to this picture. Oh my goodness. All right. Now, the chord, if both of these chords are the same length, then they're going to be the same distance from the center of the circle. As you can see in our picture, they are not the same length, therefore they are not the same distance from the center of our circle, which is point J. All right, so see this line right here and this line right here, they both cross through the center of the circle, which means that when a perpendicular bisector of a chord, perpendicular meaning it crosses at a 90-degree angle, bisector meaning it cuts it in two pieces that are equal, then they cross through the center of the circle. And that's what that map tells us. Now, we better get going because time is running out. Straight, and now a right turn, just like our map showed us. I see. All right. Now, we have found the third map. We are so close to our final destination at this point. All right. Now, our math Bible tells us that these two flaps, and that's it. These two flaps are what is encrypted into this map. You see? All right. This one right here is stating that the two chords are congruent, which means they are the same length and the same size if these two angles are congruent. As you can see, they are marked with congruency by these little dashes, and the chords are also marked with congruency by these little dashes. All right, that's very, very helpful because now we know that these two hallways are the same length. Now, If two of the chords in a circle are congruent, then their intercepted arcs are congruent. Previously, we talked about how this part is an arc and this part is an arc. Well, if these two chords are congruent, then these lengths are congruent as well. How fascinating. I think that's all. I think that's what this is trying to tell us. We are at position J, and we are trying to get to position O, right down here. Now, it won't matter which way we take, you see, because if we take J down and to L, it's not going to matter because it's going to be the same as J to K to O, you see? Or if we take J all the way around to M and up to O, it won't matter because it's the same length as J all the way to N and up to O. So, that is very, very helpful and clarifying. We are so close. We are very, very near our final prize and treasure. Where could that last scroll be? Let's see. Where is it? Oh, there it is. I found the last and final scroll to our adventure. Let's find out. All right. This one is looking much more cryptic than the other ones were. We need to figure this one out speedy-like. Now, we're back to the beginning. Do you remember in the first one when we talked about central angles and inscribed angles? Here we have a central angle in dotted line, and then we have two inscribed angles. This is much puzzling. Let's refer to my math Bible here. Where could it be? There it is. All right. Let's see. Now, the inscribed angle conjecture states that when one inscribed angle is in the same circle as a central angle, the degree value of the inscribed angle is half of the central angle. So that means that if this one is 140, as it says, then this one has to be 70 degrees. Who knew? All right, now, when we have two inscribed angles intercepting this arc right here, RS is an arc, and we have two angles intercepting it, then that means that inscribed angles are intercepted by the same arc are congruent. So when these two angles intercept the same arc, they have to be congruent. Now, that makes things quite easy for us. I guess that was just one last test to make sure that our math skills are really sharp in the noggin right here. We are at point O. The final treasure is marked with a T right here. Now, all we have to do is make a straight beeline to point T, covering the radius of the circle. And there we will find the classroom with all the answers in the whole entire school. I'm getting tingy with anticipation. With all of the answers. Oh my gosh, what does the sign say? Top secret. Students, do not enter. If you do, you ruin your education. Oh my goodness. Good for me, I'm not a student. I am Detective Anderson. Let's go. Pie. It's pie. This is the answer. The answer to all of the problems. Yes, here I have my fork. I'm gonna take a nice bite right here. Nom, 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 nom. 3.14159. Have discovered the most magical part of the school. Nobody else can know about this. You have to keep it on the down low, all right? All right? Keep it on the down low.
All right, hello, I'm Marley, and this is Akra, and I'm Detective Anderson as well. And this video was a project for school. It was a geometry project, and we had to make an instructional video explaining one of the concepts. And the concept we chose to do was chords and angles in circles.
Yeah, and pretty much the idea of the comic book was to have a place where we could record all of the things we did in geometry, and it's been really helpful as a guidebook for homework problems or tests or pretty much anything. But it's nice because you have all that information stored in one place and not like random loose leaf papers in a binder.
Yeah, so our comic book was Math Bible, and it's been really helpful on multiple occasions when we have a test and I have to study. So,
Cool. We hope you enjoyed the video.
yeah,
And thank you for watching.
if,
And it'll be on our DPs and on YouTube.
if you need to watch again, if I didn't make sense. Yeah, okay, thanks.
Bye bye.